గుడ్ ఈవినింగ్ సార్. గుడ్ ఈవినింగ్ సార్.
సార్ గుడ్ ఈవినింగ్.
గుడ్ ఈవినింగ్ సార్. గుడ్ ఈవినింగ్ సార్. సార్ ఇప్పుడు ఇది రాజశేఖర్ సార్ ఎనేబుల్ కాలేదన్నారు వాయిస్ అది.
అవునా, ఆయన కోహోస్ట్ చేశాను సార్.
సార్ అర్థం కాలేదు.
ఆయన్ని కోహోస్ట్ చేశాను. ఆయన మా ఎనేబుల్ చేసుకోవచ్చు ఆయన.
ఓకే ఓకే, ఒక్కసారి చెప్తారా? నేను ఇదే నెంబర్ నుంచి చేస్తున్నాను.
అలాగే.
ఇది రాజశేఖర్ సార్.
సార్ అప్పారావు గారు,
సార్ చెప్పండి.
అది రాజశేఖర్ గారు బయోడేటా మీకు పంపించాను.
అదే పంపించండి, చూసాను సార్.
అదే మీరు ఎవరో ఒకరు చదవాలని.
అదే మా శ్రీనివాస్ రెడ్డి సార్ చదువుతారు సార్.
ఓకే సార్, ఓకే.
అది కాకపోతే ఎనేబుల్ అయినట్లేదు, ఇంకా సార్ వాయిస్ రావట్లేదు.
నేను మాట్లాడుతున్నాను సార్.
ఓకే ఓకే ఓకే.
అప్పారావు గారు, గుడ్ ఈవినింగ్ సార్.
సార్ గుడ్ ఈవినింగ్. గుడ్ ఈవినింగ్.
గుడ్ ఈవినింగ్ సార్. గుడ్ ఈవినింగ్.
రాజశేఖర్ గారు.
రాజశేఖర్ గారు,
సార్ ఏదో ఆడియో ఎనేబుల్ కాలేదని చెప్పారు సార్.
నేను ఒక్క నిమిషం సార్, నేను మాట్లాడుతూ ఉండండి.
ఓకే
ఒక 2 minutes ఇంకా మన టైం ఉంది.
ఓకే ఓకే ఓకే.
సార్ మీరే రావాలి, మీరే రావాలి. సార్ మీరు రండి రండి జల్దీ రండి సార్ మీ గురించి వెయిటింగ్ రండి రండి.
హలో
సార్ ఈ జాయినింగ్ సార్
ఓకే ఓకే
సార్ ఆ, వినిపిస్తుందా సార్ నాది ఆడియో
వినిపిస్తుంది
సార్
సార్ వినిపిస్తుంది.
వినిపిస్తుంది.
బట్ వీడియో ఇస్ నాట్ దేర్ సార్.
మీరు వీడియో యాక్టివ్ చేసుకోలేమో సార్ తెలియదు నాకు మరి.
ఓకే సార్ ఆడియో అయితే ఓకే సార్ ఆడియో అయితే ఓకే కదా.
ఆడియో బట్ మీరు పీపీటీ కనిపించాలి కదా.
అవును కదా పీపీటీ ఒక్క నిమిషం ఐఎమ్ షేరింగ్ దట్ స్క్రీన్.
ఓకే
జస్ట్ ఐఎమ్ స్క్రీన్ షేర్ చేయాలి. Now it is okay, sir. Is it visible? Screen is visible?
కనిపిస్తుంది రాజశేఖర్ కనిపిస్తుంది.
కనిపిస్తుంది సార్. ఓకే సార్. ఓకే ఓకే సార్.
సార్ మీరు స్టార్ట్ చేయాలి సార్. మీరు ఫస్ట్ ప్రోగ్రామ్ షెడ్యూల్ ఉంది కదా మీ దగ్గర అప్పారావు గారు.
ఉంది సార్. సార్ శ్రీనివాస్ రెడ్డి గారు, సార్ శ్రీనివాస్ రెడ్డి సార్, శ్రీనివాస్ రెడ్డి సార్, శ్రీనివాస్ రెడ్డి సార్ జాయిన్ అయ్యారు. నా వాయిస్ వినిపిస్తుందా సార్? శ్రీనివాస్ రెడ్డి సార్,
లేకపోతే మీరెవరని చెప్పేసేయండి సార్. కొన్ని ఏముంది.
అంటే లేదు సార్, జాయిన్ అయ్యి ఇప్పుడు కాల్ చేశాను, జాయిన్ అయ్యా అని చెప్పారు.
ఓకే 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 ఓకే
అది అందుకు అప్పుడు జాయిన్. సార్ శ్రీనివాస్ రెడ్డి సార్, శ్రీనివాస్ రెడ్డి సార్,
హలో
శ్రీనివాస్ రెడ్డి సార్ ఉన్నారు సార్, కాకపోతే ఆయన ఆడియో వీడియో రెండు దీనిలో ఉన్నాయి.
ఓకే సార్. షల్ ఐ స్టార్ట్ సార్? మరి నేను స్టార్ట్
ఉండండి. వాళ్ళ ప్రోటోకాల్ ఉంటుంది. చైర్మన్ గారి అడ్రస్ తర్వాత లేకపోతే మీరే కాల్ చేసేయండి సార్, అయిపోతుంది. అప్పారావు గారు
సార్ చెప్పండి.
ఓకే గ్యాదరింగ్ కి అలో చెప్పేసి వీఆర్ గోయింగ్ టు హ్యావ్ ఏదో మీటింగ్ ఇట్లా ఉందండి, వన్ డే మన సెమినార్ అన్నట్టు సోన్సో టాక్ ఉందని చెప్పి మీరు ఊరికే చెప్పండి. మీ సెంటర్ గురించి 2 minutes చెప్పి ప్రొఫైల్ చదివేసి ఆయన లెక్చర్ స్టార్ట్ చేయమని చెప్పండి.
ఓకే 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 రైట్ సార్. గుడ్ ఈవినింగ్ టు వన్ అండ్ ఆల్.
గుడ్ ఈవినింగ్ సార్. గుడ్ ఈవినింగ్.
గుడ్ ఈవినింగ్
సార్. గుడ్ ఈవినింగ్. గుడ్ సార్.
Good evening, sir. I am Apparao Paila. Presently, I am working as a superintendent engineer in the Singareni Thermal Power Plant. This is a thermal power plant owned by the Singareni College Company Limited in the Mancherial district. As a chairman of Institution of Engineers India, Ramgunu Local Center for 2024 to 26, I am inviting all to the webinar on geotechnical aspects of the mine tailings, improving stability and safety, by our eminent professor Sri P. Rajshekar Garu of Mathurusri Engineering College. Before starting this session, I would like to add few things about our Institute of Engineers and our Ramgunu Local Center.
అప్పారావు గారు హలో
Sir, okay. Sir, okay. Srinivas sir, వచ్చింది మీ వాయిస్.
ఓకే అది షెల్ ఐ స్టార్ట్ ఇంట్రడ్యూసింగ్ మిస్టర్ రాజశేఖర్ గారు.
ఒక్క నిమిషం సార్, ఒక్క నిమిషం. నేను అయిపోయి చెప్తాను, అప్పుడు స్టార్ట్ చేద్దాం సార్.
ఓకే ఓకే.
Our Institution of Engineers has started in 1920 at Kolkata, and our Ramagundam Local Center is started in 2016 in our Peddapalli district, Senderi Colony in Peddapalli district. That is the erstwhile Karimnagar district. The main motto of the Institution of Engineers is to proliferate engineering education to this Peddapalli region, Peddapalli and Karimnagar region. In addition to the conducting the AMI exams, that is equal to the BTech and BE, that Institution of Engineers is to conduct seminars both offline and online on latest technologies to all engineering disciplines, from civil to latest computer technology, computer sciences and other things. In this occasion, I request all eminent engineers and budding engineers to concentrate on the basic engineering with innovative ideas to make self-sufficient India in all engineering fields. Thank you, one and all. Now our Honorary Secretary, Mr. Srinivas Reddy sir, will introduce our speaker now. Thank you.
Thank you. Thank you, Apparao garu.
Thank you, sir.
It is my pleasure to introduce keynote the speaker Dr. P. Rajshekar garu. Rajshekar garu has a distinguished career spanning over 30 years in the field of education. He has taught and contributed significantly to the subjects such as geotechnical engineering, transportation engineering, and foundation engineering. Currently, Dr. Rajshekar serves as an associate professor at Mathrusri Engineering College, Saidabad. Throughout his career, Dr. Rajshekar has held several key administrative roles, including head of department, dean, and principal. He is an active member of the Indian Geotechnical Society and associate member of the International Congress of Chemistry and Environment, and a member of the Institution of Engineers. Dr. Rajshekar has made significant contributions to research, having published 15 international and 15 national journal papers. He has also participated in 8 international conferences. In addition, he has completed a UGC minor research project worth rupees 2.4 lakh and has applied for 3 DST projects totaling rupees 66 lakh. He has guided 25 BTech projects and 15 MTech projects, focusing on areas such as groundwater contamination, ground improvement techniques, geotextiles, and geosynthesis, and soil and water contaminations. Outside of his teaching and research, Dr. Rajshekar garu has been actively involved in various extracurricular activities, including NBA, NAAC, and UGC accreditation processes. He has organized numerous workshops, seminars, guest lectures, and conferences, and has acted as Chief Superintendent for JNTUH examinations. He has also contributed to curriculum development and established civil engineering labs at Mathrusri Engineering College. Please join me in welcoming Dr. P. Rajshekar garu to start his lecture. Thank you.
Sir, good evening to all distinguished members of the Indian Institution of Engineers, Ramagundam Local Center. There is the President and Secretary, and the students of PG and UG. Sir, thank you, sir. Thank you for my introduction. Thank you very much. So today I am going to giving a webinar, a seminar topic on geotechnical aspects of mine tailings. That is improving stability and safety. So first of all, I will thank our President Apparao garu, that is the chairman of IEI Ramagundam Local Center, and Engineer K. Srinivas Reddy garu, Honorable Secretary Ramagundam Local Center, and my students of UG and PG. Thank you for joining this webinar. So my name is already introduced by eminent person. So I am Dr. Rajshekar. Presently, I am working in Mathrusri Engineering College as associate professor. Okay, so today contents of our topic is introduction. That is importance of geotechnical, consideration of mine tailings, characteristics of mine tailings, and challenges in mine tailings, stability analysis, and conclusions and references. Okay. Now coming to mine tailings. What is the mine tailings?
Sir, video share cheyaleda sir, video? Are you not sharing the video, sir?
Video. No, video naku raadam లేదు, sir.
Okay.
So there is some problem is there, technical problem is there. Is it that PPT is visible now? PPT?
Sir.
PPT visible?
Not visible, Rajshekar. Not visible.
PPT.
PPT previously it is visible, now it is not visible.
PPT.
Ashwin.
అశ్విన్ PPT వస్తలేదా?
వస్తలేదు ఇంతకుముందు కనిపించింది, ఇప్పుడు వస్తలేదు మళ్ళీ.
1 minute. There is some
Share
problem.
చేయండి. Once again, I share it.
Okay, 1 minute, sir. 1 minute.
Now it is okay, sir.
Now it is okay. Now it is coming.
Yes, sir,
Coming, Rashid.
Yes, clear.
Okay, sir. Sir,
Okay.
thank you, sir. Thank you for welcoming me. So I am Dr. Rashekar, Associate Professor in Civil Engineering Department. Today I am going to be delivering a lecture on geotechnical aspects of mine tailings, improving stability and safety is a part of lecture of the Institute of Engineers. So today I am going to be covering these are the contents: introduction of mine tailings, importance of geotechnical considerations of mine tailings, characteristics of mine tailings, challenges in mine tailings, stability analysis, and conclusions and references. So first of all, what is this mine tailing? Okay. So the mine tailings are the leftover materials or byproducts from the mining and processing of ores and minerals. These materials are typically composed of finely ground rock particles and residual materials that remain after the valuable components have been extracted. So here, what is the mine tailing? The mine tailings are nothing but so when we want to extract any minerals or any materials, any mineral materials from the ground. So first we are extracting that particular ground. Okay, so from that ground, what are the materials is coming? That material, okay, the entire material is not belongs to minerals. It may be. So what are the minerals? The mineral may be coal or iron or bauxite or something. Okay, so from that we are going to be extracting the core material or raw material, okay, which is useful for our purpose. Then what is the remaining? The remaining or we are going to be dumping at a one particular place. Okay, that is nothing but mine tailings. Okay, so here the mine tailings are the leftover materials or byproducts from mining and processing of ores and minerals. So I will show this diagram. So this diagram is now it is clearly indicating. So these are the typical examples of mine tailings. Okay, this figure is going to be showing the mine tailing and second and third and fourth. Okay. Now here, what is the geotechnical? What is the geotechnical importance of this geotechnical in mine tailings? Okay. So these mine tailings are nothing but once again it is a combination of different rocks or some different mm, soil particles. Okay, so when we are dumping this particular mine tailing at a particular place, we have to ensure the stability, safety, and environmental sustainability, and we have to maintain a proper storage facilities. That is a geotechnical. It is a duty of a geotechnical engineer. Okay, so what is the duty of the geotechnical engineering? So we have to ensure that the mine tailings should be stable and it should be safety and it should be environmental sustainability, okay, and storage facilities. Now here the stability of tailing of dams. Now in this particular aspects, so we have to prevent the failures, then we have to analyze the slope stability, then we have to control the seepage and drainage management. Means we have to control the pore water pressure, that is reducing pore water pressure within the tailing material, and we have to provide efficient drainage systems. And the third point, we have to understand that characterization of tailing material. Okay, so here the geotechnical studies evaluate the mechanical properties of tailings. Here, this mechanical property will play very important role in tailings. So, what is this mechanical properties in soil? So, mechanical properties are nothing but index properties and engineering properties. Okay. Now, coming to index properties, water content, specific gravity of mine tailing material, and Atterberg limits. And we have to classify the type of the tailing material. Is it well graded or poorly graded? And we have to know the density of the tailing material. So this will come under index properties. And what are the engineering properties? The engineering properties are going to be including shear strength, compressibility, and permeability. And one more engineering properties is compaction and settlement. Okay, so here the proper handling of tailing material prevents excessive settlement, which could be compromised the dam integrity. So this we have to take care. Okay, so we have to avoid the settlement of the mine tailing, and the mine tailing material should be properly compacted. And the risk mitigation. Okay, so this is also very important. The geotechnical expertise is vital for designing tailing storage facilities that can withstand seismic events. And we have to control the erosion and flooding control to protecting dams from external forces such as water flow or heavy rainfall ensures long term safety. So this will come under risk mitigation. And the main important thing is environmental protection. This will play safety and stability of mine tailing material. Okay, so here what are the environmental protection? Preventing contamination. Once again, what is the contamination here? The contamination here is nothing but what are the material is coming that should not be flow outside that particular boundary. Okay, now let us take if that particular material is contaminated. So what is happening? The entire surrounding area is going to be contaminated. So for that one, the geotechnical. So here we are going to be using for preventing contamination. We are going to be using the geotechnical barriers and liners can prevent leachate from the polluting groundwater. And we have to practice sustainable practices such that advances like dry staking of tailings are geotechnically designed to minimize environmental footprints. Okay, so this will come under environmental protection. Okay, the next point, characteristics of mine tailings. So what are the characteristics of mine tailing? So here the mine tailing consisting of finely ground rock and mineral waste from the extraction of metals or minerals. So it is nothing but it is a fine grounded material, which was extracted from the extraction of metals or minerals. They often contain residual metals, sulfides, and other chemicals used in the mining process. Okay. Now this particular diagram is going to be indicating the representation of mine tailing material. Now let us see, there are four diagrams are there. The first diagram, the first diagram is going to be showing. Now here we are taking some mine tailing material and I kept in a container. Okay, so in this particular container we can show some solids. This round shaped, the round shaped particles are nothing but mine tailings, and in between two round shaped particles are these are called solids. So between two solids there is a gap is there. Okay, so this gap is nothing but it is called voids. Okay, so this sometimes these voids are filled with air, water, and solids. Okay, so the first diagram is going to be indicating a tailing material, and the second diagram is going to be indicating it is a three-phase diagram. Three-phase diagram. So the tailing material we are dividing into solids and the voids. These voids. What are the voids between the two solids are filled with, sometimes the voids are filled with water and air. Okay, so this is nothing but partially saturated tailing material. Partially saturated tailing material. And coming to the third diagram, okay, if there is heavy rain, if there is heavy rain for 2-3 days, what will happen? All these voids are filled with water. Okay, so then the partially saturated tailing material will convert into fully saturated material. Okay, and sometimes in a summer season, what will happen? Due to heat or due to temperature, the water in the voids will be evaporate. Okay, now this diagram is going to be converting into two-phase diagram, but what are the voids? The voids are replaced with air. Okay, so this is the complete representation of mine tailing material. Mine tailing material. The first diagram is going to be indicating we are taking the tailing material in a container, and the second diagram we are separating into three-phase diagram, and the third diagram is going to be indicating all the voids are filled with water, and the fourth diagram is going to be representing the voids are filled with air. So that is nothing but it is a dry. It is a dry state. It is a fully saturated state. It is a partially state. Okay. So this is a representation of a material or any material. Okay. Now, so before dumping or before storing this mine tailing material, so we have to see some index properties. We have to see some index properties. The index properties are water content, specific gravity, and what type of soil, and we have to know the Atterberg limits, then density. Okay, so one of the very important index property is the particle size. One of the very important index property is the particle size. Tailings are usually composed of fine particles, often smaller than sand, but this can vary based on the mining process. This can be analyzed by sieve analysis. Okay, and what is the sieve analysis? Sieve analysis is nothing but we are taking a mine tailing material in a different sieves, and we are sieving, and we are going to be finding the particle size and sieve size. Okay, so on x-axis we are going to be drawing the particle size, on y-axis we are going to be drawing the percentage of finer. Okay, so we will get a curve. So this curve is nothing but a grading curve. Okay, so this curve will indicate what type of mining material, what type of tailing material. Okay, if this curve is S grade, if it is a S grade, so it is called well graded tailing material. Suppose if this curve we are getting a straight line, okay, it is called poorly graded tailing material. Okay, so from this particular grading curve, so we can find D10, D30, D60. Okay, so here what is the D60? D60 is nothing but the particle size at 60% of finer, and D30 nothing but the diameter of the particle at 30% of finer, and D10 nothing but the diameter of the particle at 10% of finer. Now here in this case the D10 is called effective size. Okay, and we are going to be calculating the uniformity coefficient, that is Cu. So Cu is nothing but it is the ratio of D60 divided by D10. And one more important parameter we are going to be finding, curvature coefficient or coefficient of curvature is equal to D30 square divided by D60 into D10. So why we are going to be calculating this Cu and Cc? If we are not getting this grading curve, okay, So if you are unable to understand this particular grading curve, so using these values, Cu and Cc values, we can classify the type of tailing material. Okay, if Cu is greater than 5, it will indicated well graded tailing material, and Cc is in between 1 and 3 for well graded tailing material, and if Cu is less than 3 indicates uniform tailing material. So like this we can grade. So before dumping this tailing material, we can classify what type of tailing material. Is it well graded or is it poorly graded material? Okay. Then the another thing is index property is the Atterberg limits. The Atterberg limits. The Atterberg limits are nothing but shrinkage limit, plastic limit, and liquid limit. Okay, so this particular diagram is going to be indicating the consistency of the tailing material. Okay, initially if you see the tailing material, it is solid. If I add some water, this solid will become semi-solids. If I add some more water, this semi-solid will become plastic. Okay, so at this plastic state, we can mold the material into any shape. Okay, so behind this particular water content, what will happen? This consistency, the consistent state, the plastic state will become liquid state. Okay, so these are called consistency limits or Atterberg limits of a mine tailing material. Okay, now here what is the WS? The water content between solids and semi-solids is nothing but shrinkage limit, and the water content between the semi-solids and plastic limit is called plastic limit, and the water content between the plastic and liquid limit is called liquid limit. So these are the consistency limits. Okay, liquid limit, plastic limit, and from this particular limits we can calculate indices. There is a plasticity index and a liquidity index, flow index, toughness index. Okay, and if our tailing material is very fine grained, very fine particle, so we can classify that fine particle according to this particular chart. This chart is called plasticity chart. Plasticity chart. So, what is the plasticity chart? The plasticity chart is nothing but it is a graph between the liquid limit and plasticity index. The liquid limit we are taking on a x-axis, and plasticity index we are taking on a y-axis. Okay, and there is one line is there. Okay, so this line is called A line. The name of this line itself is called A line. So here previously we saw one line. Okay, here in the grading analysis or in the sieve analysis, here we are getting a line. So this line is called grading curve. Okay, so whenever we are going to be drawing a graph between the two variables, we are getting a line or curve, and every line or every curve is having its own name. Okay, so here this name of this line is A line, and above A line, what are the tailing material? That tailing material is called clay, and below the A line, it is called silt. And if you observe in the plasticity chart, there are two vertical lines are there. So this is one vertical line and this is another vertical line. Okay. So this vertical line is at 35%, and this vertical line is at 50%. Okay. So what is the meaning? So if the liquid limit is less than 35, so it is going to be indicating with the L symbol. So what is the L symbol? L is nothing but low plasticity. And if the liquid limit is in between 35 to 50, so it is called intermediate. And if the liquid limit is more than 50, it is called high plasticity clay or high plasticity silt. Okay, so this chart is called plasticity chart. So this chart is going to be indicating fine grained tailing material. Then next, the seepage and permeability. Now, this is very important concept when we are going to be storing or when we are going to be dumping the tailing material. Okay, so before dumping the tailing material, we have to calculate the permeability. So now, what is the permeability? The permeability, yes. Any permeability. The permeability is nothing but it is property of a tailing material which permits the water through its interconnecting voids. Okay. Yes. Somebody is disturbing. Please mute. Students, please unmute your phone or system. Some disturbance is coming. Please avoid the disturbance. Okay, so this permeability is nothing but it is a defined as a property of a material which permits fluid through its interconnecting voids, and this is going to be depending upon the Darcy's law. Now, what is the Darcy law will say? The Darcy law will say that V directly proportional to I, or V is equal to K into I. Okay, so where K is the coefficient of permeability and I is nothing but hydraulic gradient. Okay, so these are the some seepage and permeability in tailing material. In tailing material. Okay, so if the tailing material is granular, so this is the permeability. Now it is a blocky and it is a platy type of slaking material. Okay. Now what is the difference between the once again permeability and seepage? Now, if you see this blocky material or granular material, so these are the solids. So this in between the two solids, there is a voids are there. So these voids are sometimes it is filled with water and air. Okay. So when the voids are filling with water, there are two types of waters. We can classify the two type of water in voids. One is held water, second is a free water. So what is the held water? The held water causes capillarity, and the free water will causes seepage. Okay. So what is the free water? Free water means it will freely move whenever there is a hydraulic gradient. If there is any gradient between the two points, that water will freely move from one point to another point. Okay, so this is the probability concept. The probability will play very important role, very important role when we are going to be storing the tailing material. Now, some factors are affecting the permeability. That is the shape of the particle, wide ratio, degree of saturation, and composition of soil particles, and soil structure, viscosity of permanent, and density and concentration of permeate. Okay, and here one more interesting topic is that how to calculate this permeability. Okay, so the permeability is calculated with help of falling head method and constant head method. Okay, so we are bringing the tailing material to the laboratory and we are doing the test. Okay, so there are two methods are there. One is falling head method, second is the constant head method. Okay, and in the field also we can measure the permeability. So there are different methods are there: pumping in test method, pump out test method, packer test method, and borehole test method. Okay, so this particular diagram is going to be indicating the permeability by the constant head. Okay, so by constant head, the permeability K is equal to QL divided by A delta H. Okay, now this is a variable head method. Okay, this is another method, variable head method, and by variable head method. So here this is the formula. Okay, so variable method will give K is equal to 2.3 AL divided by 80 into log H1 divided by H2. Okay, so this is the determination of permeability in the lab, and in the field. in the field, we can determine the permeability by pumping test. Okay, so in pumping test, the permeability here is given by this particular formula. Okay, the next, if stratified soils, if there are more than one layer, okay, if there are more than one layers of tailing materials, so it is called the stratified soil. Now in the case of a stratified soil, let us take, there are three n different types of layers, h1, h2, h3, hn, and the permeability in h1 is equal to k1 and permeability in h2 is equal to k2, and the permeability of the last layer hn is equal to kn. And how to calculate the permeability in the vertical direction? So this is the calculation of permeability in the vertical direction, and using this particular formula, we are going to be calculating the permeability in the horizontal direction. Okay, so this is the main concept of the permeability. What is the permeability? How to determine the permeability? The permeability will play crucial role in the construction of when we are going to using this tailing material in embankment or in earthen dam. Okay, then compaction. Okay, now we are going to be dumping. Now I want to dumping. I got some lot of truck, lot of waste from the mine. Okay, so if I want to reuse, if I want to reuse that tailing material uh, to construct a embankment or to construct a road. Okay, and here we have to find out the optimum moisture content and the maximum dye density of that particular tailing material. Okay, so how it is possible? It is possible by doing a Proctor test. A Proctor test. So it is called the standard Proctor test. Standard Proctor test. So this equipment is going to be showing the standard Proctor test to determine the optimum moisture content and dye density. Okay. Now here I will show a curve. Okay. So after compaction, we are going to be getting this curve. Okay, so this curve is nothing but compaction curve. Now here the peak point is going to be indicating the maximum rate density, and the corresponding water content is called optimum moisture content. Okay, so whenever we want to use this tailing material in the construction of roads or in the construction of a dam, so we have to add this OMC, this optimum moisture content, to get the density, the maximum dye density. Okay. Now this particular diagram is going to be clearly indicating the compaction curve of a tailing material. Okay. Now coming to how this tailing material is getting strength. Okay. Now there is a very important concept of this one. Okay. So the strength of different materials. Okay, so every material is having its own strength. Generally, in the construction of civil engineering structures, generally we are going to using steel, concrete, and soil or tailing material. Okay, now what is the steel? The steel is very strong in tension. Okay, so very strong in tension, and the steel is getting strength due to tensile strength. Okay, coming to concrete, the concrete is very strong in compression. Okay, so the concrete is getting the strength due to compressive strength. But what about tailing material? The tailing material is a complex material. It is a complex material, but it is very strong in shear. It is very strong in shear. So that is nothing but shear strength. Shear strength. But here we have to avoid the pore water. Okay, we have to avoid the pore water pressure. Okay, so due to presence of pore water pressure, the tailing material or soil material will behave a complex behavior. A complex behavior. Now here, how to calculate the strength of any material? Okay, now let us take a steel. How we are going to be purchasing the steel according to that grade, Fe 415 or Fe 500. So Fe nothing but ferrous, and 415 or 500 is going to be indicating its strength. Similarly, when we want to mix a concrete, so we are going for a mixed design, M15, M20, M30, M200. So what is the M? M is nothing but mix, and the next thing is going to be indicating the strength. Similarly, coming to shear strength. Okay, so here we have to find out the shear parameters. That is nothing but C comma pi, and the shear parameters will give the bearing capacity of that particular tailing material or that particular soil. So what is the steel? The steel will give a tensile strength in form of a Fe 415 or Fe 500. Similarly, the concrete will give its strength in form of mixed design M15, M20, M30, M200. Similarly, how the tailing material will get strength? Due to C comma pi, due to cohesion and friction, and that cohesion and friction will play very important role in calculation of bearing capacity. Okay. Now here, what is the shear strength? Shear strength is nothing but it is a resistance to movement between the particles due to physical bonds from particle interlocking or atom sharing electrons at the surface contact points or chemical bonds. Okay. Now, how this particular tailing material will fail? The tailing material will fail in shear. Now let us take this particular diagram is going to be showing the shear failures, shear failures of a tailing material. Okay. Now this is nothing but a sliding mass wasting. That is complete sliding of an embankment or sliding of a slope due to shear failure. And this one is going to be sinking of a footing. That is a shear failure under a foundation. Okay. Now see here, this is the sinking of a footing. How this particular material is going to be failing. Now one more failure, it is a retaining wall. Okay. So what is the retaining wall? Retaining wall is going to be retained a material, and this material is going to be exerting a pressure. Okay. So due to that particular pressure, the retaining wall will move away from the fill, or sometimes it will move towards the fill. Okay. So at the time of the failure, that is the failure surface will represents, and there will be a mobilized shear resistance. And how we are going to be getting this failure criteria in a tailing material using a Moore-Coulomb failure criteria. The Moore-Coulomb failure criteria is given by a tau is equal to C plus sigma tan pi. Okay. And here what is the tau? Tau nothing but shear strength, C nothing but cohesion, and sigma nothing but normal stress. So here we are drawing a normal stress on x-axis and shear strength on y-axis. If now we are getting a line, so this line is called failure envelope or strength envelope. Now there are the different types of strength envelopes we are getting. If the strength envelope is going to be passing through the soil, so it is called cohesionless soil. And if it is parallel to the x-axis, it is called cohesive soil. This line is going to be intersecting the y-axis at a particular point. So this is called a general case, that is the C-pi soils. Okay. The Moore-Coulomb failure criteria will give the strength envelope for cohesive soil, cohesionless soil, and C-pi soils. Now, the determination of shear parameters are very important. So, how we are going to be determining these shear parameters? So, by testing the tailing material in a lab with the help of a direct shear test or triaxial shear test. And in the field also, we can test by vane shear test, Darwin test, packet penetrometer, fall cone test, pressure meter, static cone penetration test, and standard penetration test. So using this particular test, we can calculate C comma pi, If I know the C comma pi of any material, I can calculate the bearing capacity. Okay. And one more important failure is a slope failure. Okay, sliding of a slope, that is embankment. Okay, embankment failure or slope failure. Okay, so this example, so this failure will occur in Sikkim Gangtok in 1970s. There is a heavy rainfall. There is a heavy rainfall. Due to that particular heavy rainfall, this entire soil mass, this entire soil mass will failed, and there is a lot of human loss and lot of property we lost in that particular failure. Now these are some failure mechanisms. Failure mechanisms are slope sliding mechanisms. Okay, so this is one type of slope failure. This is another type of slope failure. This is one type of slope failure, and this is another type of slope failure. Okay, this is also slope failure. Okay, now here, how this particular slope is going to be failing? So before going for analysis, there are two types of slopes are there. One is a finite slope, the second is a infinite slope. Okay, and uh, by nature, if the slope is formed by nature, so it is called a natural slope. If the slope is made by the man, so it is called man-made. So what are the man-made slopes? Construction, that is the cutting and filling or embankment or earthen dams. Now here, now that types of failure. There are three types of slope failures. One is face failure, second is the toe failure, and the third is a base failure. Okay. So here I covered. So this is example is going to be showing the face failure and toe failure. Toe failure means so the failure is going to be starting from the toe. So face failure is nothing but the failure is going to be starting from the here above the toe. Okay, and one more failure is base failure. One more failure is base failure. Okay, so when till now what I was covered, I covered what is the tailing material, and when we are going to be storing the tailing material, so we have to know the mechanical properties. The mechanical properties are nothing but index properties and engineering properties. Okay, so what are the index properties? Water content, specific gravity, outer work limits, density, and are fall in the index properties. And what are the engineering properties? The engineering properties are permeability and shear strength. And meanwhile, after making a tailing material as a slope, we have to analyze the stability of the slope. Okay, so these points we have to remember when we are going to be uh, storing any tailing material. Okay, so by this I am going to be stopping my lecture. Now it is the time to ask some questions. Please ask any questions. Or you can type in chat box. If you are having any doubt, you can, there is a chat box is there. Okay, I got 5
Apparao garu.
charts. Huh? Okay.
Thank you, Rajshekar sir.
Thank you, sir. Thank you. Any
Thank
doubts?
you.
Any doubts from the audience, please? Students, please you ask the questions. Then only
I have a doubt, sir. Rajshekar sir. This
sir,
is
sir,
Dr. Manohar.
our HOD.
Our students won't ask the questions.
No, sir, sir. They will ask, sir. They
My
will.
question is, sir, in mining, the tailing material,
Yeah.
how will be that the cohesion will be more? I
No,
think,
no. It is depend upon the what mineral. It is depend upon the type of the mineral. If it is a coal, if it is a coal material, then the friction is very less. It is a cohesion. If the material is a iron or bauxite,
Okay.
then the friction will be more.
Acha.
That is the difference. Students, please ask some questions. Okay, what is the importance of seepage? Very good. I got some chart box. What is the importance of improving stability of mine tailing? Very good. So this is a very good question asked by one of my student. So here the stability analysis will play very important role when we are going to be storing the tailing material at one particular point. Okay. So what is the stability? The stability is nothing but so we are going to be providing the maximum dry density or maximum density. Okay. So if there is no any maximum dry density, what will happen if there is heavy rain? Heavy rain will fall. So that entire material will be washed out. Washed out. Okay. So here before storing we have to find out the shear parameters and depend upon that particular shear parameters, and we have to compact that particular tailing material, then we will get the stability. And the second question asked by some student, what is the importance of seepage? Very good. So this is also very important in case of mining. So when we are digging the coal, okay, in underground mining, we will get a lot of seepage. We are going to be getting a lot of seepage or lot of water. So we have to dewatering. We have to use some dewatering techniques to remove that particular water. That is called seepage analysis. Okay. The next question is all types of tailing material give the same results to withstand the failures? No, no, no. So it is depend upon the type of mineral what we are going to be extracting from that particular ground. Okay. So if it is a coal, we will get a different type of results, and if it is a iron ore, we will get a different type of results in failure mechanism. If it is a bauxite material, then we will get a different.
Sir, good evening, sir. Rajashekar, sir.
Sir, good evening, sir. Good evening.
Your lecture is very elaborative, sir. In coal mining scenario also, we remove this overburden, and there are also different soils, and we store the different soils with the different heights also.
Yes,
And
sir.
while removing coal, we get this overburden. This is stocked systematically, and before stocking also, we remove the subsoil to hold the weight of the tailings or overburdens. So on the whole, the lecture is enriching and very elaborative. Thank you, sir. Thank you very much.
Thank you, sir. Thank you very much. Thank you.
A very good afternoon to all. On behalf of everyone here, I would like to, and also on behalf of the RGM Local Center, I would like to express my sincere thanks to Mr. Apparao, President of Local Center, for arranging and organizing, conducting this insightful seminar. His leadership and efforts have made this event a success. I would also like to extend my heartfelt thanks to Rajashekar sir for delivering highly informative lecture on mine tailings and this improving stability and safety of the overburden dumps. A special thanks to all the participants for active involvement and engagement throughout the seminar. With that, I officially conclude this seminar. Thank you once again to everyone for your presence and contribution. Thank you, Rajashekar sir, once again.
Thank
Thanks
you.
to
Thank you, sir. Thank you.
Thank you, Rajshekar sir, and I'm
Thank you, sir.
lecture.
Thank you to all.
Thank you, professor, and organizers. Thank you, organizers also. Thank you.
Thank you, sir. Thank you to one and all.
Thank you.
Thank you very much.
సార్ డాక్టర్ ఏఎస్ రెడ్డి గారు, ప్రిన్సిపల్ సిఎంఆర్ ఇంజనీరింగ్ కాలేజ్. థ్యాంక్ యూ సార్, థ్యాంక్ యూ ఫర్ జాయినింగ్.
Namaste, sir. Thank you, sir. So
Thank you,
nice.
sir.
Thank you.